During snowfall, snow begins accumulating on the top of an air-supported structure. This snow accumulation at the top of the dome creates additional load on the membrane and increases structural stress on the entire structure. If the snow is not removed quickly enough, the increasing snow load can become a serious risk for the structural stability of the air dome. For this reason, all air domes use heat to reduce snow accumulation on the outer membrane. However, there are major differences in how air dome technologies achieve this process. In old-generation double-membrane air domes, the double membrane system is formed by multiple pressurized air pockets containing static trapped air between the membranes. Under normal conditions, these air pockets improve thermal insulation. However, during snowfall, these static air pockets become a limitation, preventing heat from efficiently reaching the outer membrane surface where snow accumulation occurs. As a result, the warm air inside the air dome remains trapped within the interior space and cannot efficiently support snow melting on the outer membrane, where snow continues accumulating intensively. As a solution during snowfall, old-generation air domes rely on manually operated pressure release valves on the air pockets, which must be opened on-site by the operator. After many pressure release valves are manually opened, the pressure inside the air pockets is removed, and the internal pressure of the air dome pushes the inner membrane against the outer membrane, causing the double membrane system to lose its insulating air layer and turn into a poorly insulated single membrane structure. This approach creates several major disadvantages. In old-generation air domes, preventing snow accumulation requires heating the entire interior air volume of the dome. This large volume heating leads to excessive energy usage, simply to initiate snow sliding from the membrane. Another major limitation is overheating. To force sufficient heat transfer through the membrane system, the interior must be heated above normal comfort and cost-efficient operating levels. This also results in continuous high-level heating during snowfall periods, regardless of actual facility usage. Another characteristic of old-generation systems is manual release. Operators must physically arrive on site and manually open pressure release valves on the air pockets to allow heat transfer toward the outer membrane. All of this creates increased structural risk during severe snowfall conditions. Because the system depends on manual intervention, large volume heating, and inefficient heat transfer through the membrane system, snow can continue accumulating on the structure, increasing the risk of structural collapse. DUOL's patented 1+1 membrane system works on a fundamentally different principle. This next-generation system integrates two completely separated air domes, positioned one inside another, creating a continuous intermembrane chamber between the inner and outer structure. This open intermembrane space allows dynamic airflow to circulate continuously across the entire membrane surface, enabling highly efficient heat transfer and snow sliding performance. Unlike traditional air pocket systems with static trapped air and separated chambers, airflow inside the DUOL system remains continuously moving rather than trapped in isolated pockets. A dedicated air handling and heating system independently controls airflow for both the occupied interior space and the intermembrane chamber. Under normal operating conditions, the interior of the air dome maintains standard comfortable temperatures. During snowfall conditions, only the intermembrane chamber is selectively heated, meaning that only a small air volume between the membranes requires additional heating, unlike traditional air dome systems where the entire interior volume must be heated. This advanced combination of dual membrane architecture, independently controlled airflow, and targeted intermembrane heating forms DUOL's innovative SnowDefender technology. This fundamentally different operating principle not only significantly improves energy efficiency, but also provides several additional key advantages. In old-generation air domes, snow protection requires heating massive interior air volumes, resulting in significant energy waste. With DUOL's SnowDefender technology, only a minimal interspace volume between the membranes requires additional heating. This dramatically reduces energy consumption while maintaining highly efficient snow response performance. Traditional systems also rely on overheating the entire interior space in order to transfer heat toward the outer membrane. With SnowDefender technology, the occupied interior space remains at normal operating temperature, while snow response heating is applied only inside the intermembrane chamber. Traditional air domes require continuous high-level heating during snowfall conditions, regardless of actual facility usage. With SnowDefender technology, snow response heating is localized only to the intermembrane chamber where snow melting is required, while interior heating remains independently controlled according to actual occupancy and operational needs. For example, during nighttime or periods without users, interior temperatures can remain significantly lower without affecting snow response performance. Another major limitation of traditional systems is manual pressure release and operator intervention during snowfall conditions. SnowDefender eliminates this process through fully automated airflow and heating control without manual pressure release. And finally, while traditional systems face increased structural risk due to slow response and delayed snow melting, SnowDefender's dynamic interspace airflow enables significantly faster snow melting and snow sliding performance. The result is a significantly more advanced snow response system with superior energy efficiency, optimized heating control, fully automated operation, improved structural stability, and more reliable performance during severe snowfall conditions.